All right, let's get started. So we are talking about composition of functions today, a new section. And this is really where 1400 starts. Okay. Starting today, psych teacher doesn't do anything now. Oh no. Yeah, I think a lot of people are just, sorry. I think a lot of people are just trying to figure out what works. And then like when they were planning things, they said, this would be a great idea. And then they started doing it and they went like how with our quiz uploads, we upload your solutions randomly. Just some people can't upload to Canvas, which is super weird. I have not figured out really a great alternative, but we'll just kind of figure it out. Worst case scenario, you can always email me the work and stuff like that. So this is this is really where 1400 starts. Okay, we did a lot of review, and starting in this section, it's gonna get tricky. Okay, we got started a little tricky in the last section, and now we're really into it now. Okay, so watch out, do the homework. Even again, as a reminder, even if you get a B on your quiz and you don't have to submit the homework, please at least just look at some of the problems. Take like 5-10 minutes or something, and make sure that you can do one of each type of problem before the quiz comes around. Would be a very good idea, and ask questions as you have them. All right, quadratic functions were review. Graphing was mostly review. Domain and range was like some review. Complex numbers was almost all review. This is new stuff though. This is bona fide new stuff. This is some new good stuff. So we're gonna try to spread these sections out over multiple days. Maybe like do 2/3 of a section in a single day or something, and take the time where we need it. So here's what I'm gonna need from you guys. I can't, so like in class, right? In class I can teach and I can look out and I can see 20 people going, but it's harder to do that here, okay? So provide as much feedback as you feel capable with this stuff, and that'll help me get a good idea of how fast to go. Because we have material we have to cover, so we can go faster on some sections and slower on some sections, but the total amount of material we need to cover needs to be the same, okay? So, so we'll see things. I think most of today won't be too bad. The worst part of this section is probably going to be covered on tomorrow. All right. Okay, so I'll try to explain things, and if you have questions, feel free to just type them out at any point. I don't even have to be asking for questions. You can type out and say, hey, what does composition mean? And I'll tell you. Okay, so really this whole chapter, I am really talking a long time. We still got a long time left. I'm going to try to keep these lectures to an hour. I think 75 minutes for a video lecture is way too long. I'm going to try to keep them to an hour or so, and then 15 minutes at the end if people want like to ask questions and stuff, they can do it. Otherwise we can end early. 75 minutes I think is just too much. Let's get into it. So in this chapter we're talking everything about functions, and today we're sort of going to be talking about addition and subtraction and multiplication and division. Easy stuff, right? Everyone is good with their arithmetic. Really today is just a lot of arithmetic, okay? Just masqueraded in an interesting fashion using functions. Okay, so I'm gonna skip the intro. There's a cool little intro I do in class, but I'm gonna skip that. Let's just get to the facts. Okay, we're just gonna list out all the operations and then we're gonna use them. Okay, so it's gonna be kind of boring. Just gonna write down a list, but then we'll use them, and it'll maybe still be boring. But we're gonna start off with some easy stuff. Yeah. All right. So this is mostly just notation. So when we write f plus g of x, all this means right here is just find what f of x is and find what g of x is and add them together. Okay, that's all this is. It's just new notation. This is a new function called f plus g. We're just evaluating it at the point x, and that's all it means. All right, and of course, we can do this with subtraction, multiplication, and division as well. So I'm just going to write those down really quickly because it's all the same thing, right? If f plus g is just f of x plus g of x, f minus g is, of course, going to be f of x minus g of x. No, this is not review for probably almost everybody. We have left the realm of review behind. Okay? I do not expect anyone to have seen this unless you've taken the class before. This is getting into stuff that I don't expect you to. Previous stuff was review. But this stuff is some new stuff. And this is going to give us a lot of power to do what we want with functions. And we can use them in ways you never thought possible to achieve things you never dreamed of. All right. So there's also f times g. We just write them next to each other, just like 2x, f times g. And that is, surprisingly, f of x times g of x. Okay. Function composition is actually not used, a little bit in trig. It's used a little bit in trig, mostly just for inverse functions. One of the big things about function composition really does have to do with inverse functions, which we'll get into 3.7, which we should, hopefully we'll get to 3.7 by the end of the week. We should be able to get to 3.7 by the end of the week. That's a good section, inverse functions. That's a juicy section. All right, and surprisingly enough, there's also division, okay? So that is just, surprise, surprise, f of x divided by g of x. Really, this whole class, 1400, kind of tells a story like 930 did. 930 told the story of, hey, it wasn't a very good story. Never mind that. And there's one more. We did addition, subtraction, multiplication, and division. And the fifth one is really juicy, okay? It's got a lot, it's like a really ripe fruit that you just want to sink your teeth into. All right, addition, subtraction, multiplication, division. Now we're doing function composition. Okay? This is the weird one. This last one's the weird one, and it's the important one, the most important. And that's going to be f composed with g of x. That is f of g of x. So this one's the different one. Okay? Math is really a lot like cooking, all right? Yeah, exactly, antonymity. So that's what we have here. So notice this is an open circle. This open circle, this is not multiplication, okay? So do not confuse composition with multiplication. This one is the big ticket item over here. Yeah, if you remember Fogg and Goff from earlier days, that's this. Hey there, Erica. Hope you're doing well. So these are all the function compositions. We just list them all, and now we're going to use them all. Function composition is the most interesting. Function composition is usually the most confusing as well, especially when we talk about domain and range. Okay? Domain and range is going to be, I need to think of a new metaphor. It's going to be a prickly part of the section. Okay? So let's do an example, shall we? Example 1. Find and simplify for these given functions. Let's see this in action. You're probably going to think example 1's easy, okay? But if you don't think example 1's easy, that's okay too. All right. So for f of x equals to x minus 1 and g of x equals x squared minus 1. Yeah, no pressure. It's never good to say something's going to be easy, because then if it's easy, you think, oh, well, this is just easy. And if it's not easy, you think, oh, I'm an idiot, even if it's not true. So part A. Find g minus f of x. So it looks weird, but let's just use the definition, right? What does it mean, g minus f? Well, it's probably going to have something to do with f minus g. Just switch the order. F minus g of x is just the function minus the other function. So this is just the first function minus the second. Right? So that's just g of x minus f of x. Well, f of x is x minus 1. Plug that in. G of x is x squared minus 1. Plug that in. Okay. Now you got this, Lexi. As soon as I do part A, you're going to be bored. All right. So we got g of x minus f of x. Just plug that in. So g of x is x squared minus 1. All right. That's just g. Minus f of x, which is x minus 1. And remember, watch out. We're subtracting the whole thing of f of x. So we need to subtract the whole function x minus 1. So you need these parentheses. Okay. No forgetting parentheses. And we just simplify. So we get x squared minus 1, distribute the negative, minus x plus 1. Oh, how exciting. Look what we got here. We got a minus 1 and a plus 1. They're going to cancel each other out. Okay. So what we're left with is just x squared minus x as our answer. So if you have one function and another function, you can make a new function by just subtracting them. And that's what we did. We made a new function, g minus f. And that's what we found it to be. Exactly, just replacing things. It's a good way to phrase it. So with your pencil and paper, or your pen and paper, which you should have out in front of you, look at B. Do the same things for B as we did for A. Find what f divided by g of x is. Use the definition and plug things in and simplify. Okay? Take a minute to do this one. And ask questions if you get stuck or have questions. Okay, here's what you should have gotten. The definition. F divided by g of x is just the function f divided by the function g. So write that down. F of x divided by g of x. Calling for help sounds much better. I shall answer. We have f divided by g. What is f? F is x minus 1. So you just replace it. You get x minus 1 on the top. What's g? G, we said, was x squared minus 1. And you say, okay, well, we can't simplify it anymore. I guess we're done. But this is some good news. You've been missing Math 930. You've been missing our last class. Well, you get to do it again because we can simplify this. This is a rational expression just like we did at the beginning of the semester. Wow. How fun. So we can't simplify it yet because it's subtraction. No cancellation here. You cancel this, I'll get very upset with you. We have to factor it before we can simplify. And I want to fit it all on the same page, so we're going to go up here. The top is just x minus 1, but the bottom is the difference of squares. X squared minus 1 squared is x minus 1. X plus 1. Now the x minus 1's canceled. So we're left with 1 divided by x plus 1 is our answer. All right, so I give you a little trick one right here. All right, a little throwback to 9:30. Okay. It's better practice. It challenges you. If you only do easy stuff, you never grow. I'm giving you ample opportunities for growth. All right. Any other questions on B before we do another one? X squared minus 1 is not the same as x minus 1 squared. No. Sorry. So I said it. The way I said it was right, but it's not really. This is what I meant. Not this. So this is why we could use the difference of squares formula right here. Okay. You don't know this? Well, you're learning it. You're learning it. It makes sense now, though, right? Just use the definition, replace the f of x with what it equals, and the g of x with what it equals. And then the simplifying, I know you know, because I passed all of you. So I know you know this step. If you've forgotten it, that's fine. The exactly antonymity. All right, good. Let's keep on going. Keep up the feedback. Keep up the feedback. Let's do a different example. So we mentioned, right? These four are kind of tedious, and I got to be honest, your homework is a little tedious for this section. But this fifth one is the real standout performer. If we've all been there, right? You're watching a play or you're watching a movie, and like most of the actors. Let's say movie. Most of the actors are just so boring. And then you got like this one person who's carrying the show. That's the composition right here. That's the function composition. Like Adam Driver in the new Star Wars movies. Okay. Oh, hi, Kinley's mom. Let's do example 2. Because we haven't done example 2 yet. All right. 4, f of x. He's the driving force. For f of x equals 2x plus 1. And g of x equals 3 minus x. We should have a bring your mom to class day. I think that would go really well. Find the following. And if you don't have a mom, you can bring your cat. That's kind of a dark thing to say, isn't it? I apologize. Let's move on. Find f of g. Okay, find the fog. All right, so we just go back to our definitions. All right, what is f of g? Find the definitions. F of g is, what is this? This says that we have a function, and I apologize. This is really where the section really kind of is a little rough. Okay. The function composition has tended to be a little tricky for a lot of people. So this is what we're doing. F of g of x. Let's just write that down. Okay. So we need to start on the inside. Order of operations, right? We always start on the inside of the parentheses and then we work our way out. Okay. Exactly. We're going to evaluate the g and then use that to evaluate f. So starting on the inside, what is g of x? G of x is 3 minus x. In math, if things are the same, then they are the same. Like the same. The same. So if I tell you that g minus x is the same thing as 3 minus x, I could write a 3 minus x here, and you don't even know the difference because they're the same thing. You can't tell I change anything. Say, Jason, what did you do from this step to this step? They look identical because g of x is just 3 minus x. Same thing. It's not an asterisk. I forgot to write of x. So I tried to squish it in there. Yeah. So now here's when things get really, really tricky. I'm going to go off to the side real quick. I'm going to take all of you on a trip down memory lane. Now, the x is supposed to not confuse you. This really is just f of g of x. Right there. It's a function just like f of x. Trip down memory lane, everyone. Recall, right? When we had functions, when we had something like this, and I said, well, what is f of a? Remember when we did this? We said we just replace the x with a. You get 2a plus 1. Or what is f of 2? You just replace the x with 2. You get 2 times 2 plus 1. You can simplify that. That's 5. Or f of a plus 1. You replace the x with a plus 1. And you could simplify. Remember when we did this? We did this in 930, and we've done it a little bit earlier on in the section. So we're doing the same thing here, exactly. We're replacing the x right here with what's on the inside, because we don't have an x, we don't have an a, we don't have a 2, but it's the same logic as what we did earlier. So f of x, right, is 2x plus 1. But this is not an x. This is a 3 minus x. So everywhere that there used to be an x, we replace with a 3 minus x. And this step right here is this probably the single most confusing thing of the whole section. So it's very, very important that we talk about this a lot. All right. It's just the same as what we've done before. You're just replacing the variable with whatever's on the inside. And that's what we're doing here. We found our function. It's 2x plus 1, but we're replacing the x with the inside, so it's 2 times this plus 1. Okay? Any questions on this before we simplify it? No, we have to simplify it a little bit. But this is most of the answer. Oh. So to simplify, we distribute. Doop doop. I think I should do more sound effects. This would be good. 2 times 3 is 6. Minus 2 times x is 2x. Plus 1. We just add the 6 and the 1. 6 plus 1 is 7. We get 7 minus 2x. This is our answer. So, you want to know a really common time where we might use function composition outside of inverse functions? This is what I usually start the class with. Don't mind the paper. It's a little crumpled. It's a little dried out. One of the times you can use function compositions is look at this formula, right? This converts Fahrenheit to Celsius. Take 5/9 of Fahrenheit minus 32 to get to Celsius. And the formula for Kelvin is a Celsius plus 273.15. So function composition can be used to make a formula that takes Fahrenheit directly to Kelvin. That's essentially what function composition is. It's combining 2 steps into 1. Okay? So let's do another one. We'll do another one together before I tell you that you should have perfectly learned it all and can do it on your own. All right, let's do part B. Find g of f. So small note, when we write g of f without the x, that just means the function itself. But most of the time, we also talk about it with the x. And this is essentially, there's a lot of nitpicky differences about these two things. But suffice it to say, for most of you, you can just treat them exactly the same. Unless you really want to get in depth on like the theory of how functions work, okay? So realistically, when you're asked for this, you just want to find this, okay? All right, so let's do this one. It's going to be very similar. We start with the definition. What does function composition mean? Well, we go to our list of function operations. We say function composition. Well, that just means that you take the inside function and evaluate it for the outside function. Okay? So f of g is f of g. This is how we say it, right? F of g. That's how we say it this way and this way. Sometimes you might say, if you're talking to someone who's like really pretentious, they might say the composition of f and g, or the function f composed with the function g, or something like that. But mostly we just say f of g. Okay. Whew. Holding back a sneeze. So this is going to be g of f of x. And now we just do the same steps. Start on the inside and work our way outside. Yeah, I should have worn my suit and tie if I'm going to talk like that. Out of all the people I have met, professors tend to be the most pretentious. But there's a lot of groups of people I haven't met. But yeah, we're kind of most of us are a pretentious lot. Hold on. Think about the next couple steps here. You don't have to do them, but think about the next couple steps. Okay, so now what we've got to do is plug in the inside. What is f of x? Okay, we have to find out what f of x is, because we are taking the composition of the function g with the function f. So we start on the inside, work our way out. F of x, well, we just said that's 2x plus 1. So if f of x is 2x plus 1, replace it. Good day. Just wait till I bring out my wigs. I haven't worn the wigs for a long time. I've got some quality wigs though. Although that starts to go down a rabbit hole that I really, really don't want to go down with the class, I think. There's a lot of interesting stuff down that rabbit hole. And anyone who exposes me, by the way, is getting banned. There are many... Anyway. So what do we do next, right? We need to evaluate the function g when the input is 2x plus 1. Okay? What was g of x, right? Remember, g of x was 3 minus x. So we're replacing the x with this. Okay? So it's 3 minus x. Oh, not x. It's 3 minus this. Replace all the x's with this. So it's 3 minus 2x plus 1. All right? And this is a big step. Here's the deal. Here's the deal. If you remind me next week, you have to remember a whole week. If you remind me next week, I will bring out the wigs. So, what we got right here is 3, distribute the negative, minus 2x, minus 1, collect like terms. 3 minus 1 is 2. We have 2 minus 2x as our simplified function. The input is always the inside function. Yeah, exactly. All right. So that's g of f. So notice f of g and g of f are not the same. Composition is not commutative. Right? Talking about stuff that is commutative, addition is commutative. X plus 2x is the same as 2x plus x. These are the same. Subtraction is not, right? If you flip the order on subtraction, these are different things. Multiplication is, division isn't. This is not. All right. It's like the pebbles in my shoes. I did take a week to act on the pebble in my shoe. You're using the wrong metaphor to convince me. All right. Here we go. This is the problem. So we're going to do a fun example, and it's going to be a little fun, I think. Yeah, this is what happens in the actual classroom too. This class gets riled up real easily. They're a fiery bunch. Let's do part C. Right? And again, recall same f of x. F of x is 2x plus 1. G of x is 3 minus x. I'm just writing this down so you can still see it. You don't have to copy it down again. What is f of g of 2? There's no x anymore. Now there's just a 2. This should be easier. I want you to try to do this one. Take a minute. Start on the inside and work your way out. Okay? Take a minute. Approach this like we approached the previous ones. And again, if you didn't write it down, I'll show them a little bit. Three is the correct answer, yeah. I'll give half a minute more for people to get to 3. Kinley, did you get 3? So there's 2 ways of doing this problem. We're going to do them both ways, but one of them is super quick. Good, good, good. So let's look at this. So if we use the definition, right? We just have f of, well, what's g of 2? In the previous text, we plugged in g of x, but now we're plugging in g of 2. What's g of 2? G of 2 is 3 minus 2. Let's simplify that a little bit. 3 minus 2 is just 1. This is the same thing as f of 1. Well, now this is easy. This isn't function composition at all. We just take f and plug in 1. We get 2 times 1 plus 1, which is 3. Now, what you could have also done, right? There's 2 ways of doing this. In part A, right? We already found that f of g of x was 7 minus 2x. We already found this in part A. So, if you are really lazy, and math kind of rewards laziness, you would have said, I don't want to do this out again. We already did this. We already found that f of g of x is 7 minus 2x. So that f of g now of 2 is just 7 minus 2 times 2, which is 3. So that's the quicker way to do that, since we already found it. All right. But I intended for you to do it this way, by the way. I intended for you to do it this way to get more practice. But you could have already done that since we found it. Okay. Any questions on this before we go on to page 2? Page 2 is fun. So we've essentially covered the heart of the section, and now we're just going to look at it from different points of view. And then the part of the section we're talking about tomorrow is not fun anymore. Yes, fog is the same as f parenthesis g. Yes, good question. To write down what was said, or what I think was said. Right, this is true. So kind of like this as well. So let's go on to example 3. So the function c of s, and again, you can use any letters you want for a function and any letters you want for a variable. Now you always write the order the same way. So if you are f of g here, oh, oops, I wrote it down wrong. It's f of g, like this. Sorry. You always write them in the same order. This was a typo. Can you have a typo when you're writing by hand? Thank you. So the function c of s gives the number of calories burned after s sit-ups, comma. Okay? So again, this is a function that if I give you a number of sit-ups, if I give you an input, s, you can plug that into the function c to get how many calories were burned. Okay? And then I'll give you another function. S of t gives the number of sit-ups, again, same s, a person, let's call the person Joe. You guys remember Joe, right? Can complete in t minutes. So I have two functions here that we're talking about. Two functions, c of s and s of t. And we're going to compose them and say, what is this talking about? And it's like going on that Fahrenheit and Celsius and Kelvin thing I was talking about whenever I was talking about it, okay? So let's look at this. Part A. What does c of s of 3 mean? So this is function composition. We are composing the function c with the function s, and we're evaluating it at when t is 3. Okay? So, any ideas? We can't evaluate this, right? We can't evaluate it because I didn't give you what the functions were. I'm just saying, what does it mean? But we can still kind of approach it the same way, right? Remember, this thing is the t, s of t. So s of t gives the number of sit-ups a person can complete in t minutes. Yeah, exactly, Zwoto. So what we have is after 3 minutes, how many sit-ups are they going to do? And then, okay, we're going to use that many sit-ups to figure out how many calories burned. So the final answer is going to be a calorie. Yeah, so exactly. How many calories? The answer is the calories burned after 3 minutes of sit-ups. Okay. And so that's one usage of function composition. If I didn't, what if I don't care about how many sit-ups they did? Let's skip the middleman. If I only care about how many calories and how many times, you could talk about function composition like this way. Okay. So let's do part B. This is a trick question. Does S of C of 3 mean anything? Okay. So let's talk about this. What does C of 3 mean? C of 3 gives the number of calories burned after 3 sit-ups. All right, so that's what this is. Number of calories after 3 sit-ups. But we can't plug in calories into the S function, right? This doesn't make any sense because this inside is a number of calories, but the S function takes in time. You can't plug calories into a time function, right? S of t only takes time as an input, not calories. So over here, the 3 represents a t because it's S of t is the function. Over here, the 3, I should use a different number, represents an S because C of S is the function. Okay, you're not going to see anything like B. I'm only talking about B to kind of show the importance of domain, which we're going to get into later. So if B doesn't make that much sense, you can ask questions to learn more. But realistically, it's just to show you, it's just to give you a little taste of why domain is important, because we're going to be talking about that tomorrow. All right. A is the really important one for example 3. Let's do example 4. You'll like example 4. I think you'll like example 4. Example 4 is going to be like a breath of fresh air. Like is maybe a strong word. You might not hate it. So I'm going to give you a table. Not a kitchen table, but a mathematical table with 3 columns. X, f of x, and g of x. Okay. And our values for x, we're going to have really great values of x. 1, 2, 3, 4. Those are good inputs. All right. I can't wait till it's like warm enough that I can open my window. I think I love smelling fresh air, actually. In f of x, it's going to be 6, 8, 3, 1. And in g, it's going to be 3, 5, 2, 7. So this is just a table showing some of the values of f and g. All right. So to solve this, we have to know the question. You have to be asked the question first. Okay. Part A. Find f of g of 1. More function composition. Function composition. Wow. Kind of fun. All right. So, what is g? What is g of 1? Remember, you always start on the inside and work your way outside. Okay, so what's g of 1? We need to find our table. Somebody in the chat, tell me what g of 1 is here. Yeah, g of 1 is 3. Yep. When x is 1, what is the value of g? So you find when x is 1, what is the value of g? And you get 3. Well, and now we just need to find what f of 3 is. So we just do the same thing. All right. Yeah, I'm ignoring my non-students cooldown. I apologize. So f of 3 is, oh man, when x is 3, f is also 3. So many 3s. We had 3s in example 3 as well. And we just did example 3. 3s everywhere. Some like conspiracy level stuff. All right, good. So this is not too bad, right? Let's do one more. No, you do the second one. You do part B. Find what g of f of 4 is. Okay, and if you get the answer, go ahead and post it. If you're confused, where did I lose you? The half angle of the beast. Part A. So we're doing function composition before. So question. I'll ask, we'll do things one at a time. Are you okay with the fact that g of 1 is 3? we don't know what the function g of x is, but are you good with the fact that g of 1 is 3? Okay, good. So then this is what we have to find. Since g of 1 is 3, we replace the g of 1 with 3. They're the same thing, so we can just replace it. And then we just need to find what f of 3 is. And again, f of 3 is 3. Does that answer the question, or are there more questions? If there are, if you're still confused, please ask. Yeah. Why wouldn't it equal 9? I don't understand why it would. Why don't you multiply? Oh, because this is f of 3 is equal to 3. It's just like if you have f of x equals to like x squared plus 5, and I ask you what is f of 1, you just plug it in and you get f of 1 is 6. You get a value. This isn't multiplication. This is just what is the value of the function when your input is 1. So when x is 3, the function value is 3, like so. There's just too many 3's to keep up, yeah. If you were asked f of g of 2, you would not be able to solve that. No, I would not ask you what f of g of 2 is. Good. Any more questions? Did this answer your question about multiplication, Natalie? We can do it again in part B. So for part B, right, first we always have to start on the inside. We have to find out what f of 4 is. Okay, good. So we go to our function. When x is 4, f is 1. Yeah, good, Erica. So we replace the f of 4 with 1. And it simplifies now to g of 1. All right. So now we consult the table again. When x is 1, what is g? When x is 1, g is 3. So, oh my word, too many 3's. The g of 1 equals 3. So 3 is our final answer. Again. The conspira3, yeah. So what I want you to do is part C. I want you to do part C on your own. And let's see. I'm trying to come up with a problem that doesn't have 3 as the answer. All right, find f of g of 3. Okay. Take a minute or so. Oh, and in case you haven't written it down, well, I can't show the table on this at the same time, actually, unless I do something really creative. There we go. The attendance question has not yet been asked, but there will be one. So go ahead and do this on your own paper. Hopefully 3 is not the answer. Yeah. So what we have here, right? We need to find what g of 3 is. So we go off to the side and say, what's g of 3? Okay. So when x is 3, g is 2. So g of 3 is just 2. So we replace the g of 3 with a 2, like so. And then we need to find, well, when x is 2, what is f? When x is 2, f is 8. All right, so we get 8 as our answer for part C. F of g of 3 is 8, which, by the way, is 3 squared minus 1. If you're missing 3's, if you want to think about how the answer relates to 3's. Because apparently this is now a 3 class. Only 3's. Okay, good. Any more questions? Otherwise, we're going to go on to the next problem. I like the sound of paper. Exactly, Alex. Well said. Example 5. What if we start talking about graphs? What if we combine function compositions with graphing? Well, you're going to find the answer to that question right now. All right, so consider the following functions. All right, we'll start off with 5, a 5 by 5 graph. We may need to make it bigger though. So this first function starts at the point 3, negative 1, and it's a parabola. So it also has the point 4, 0, and 2, 0, and it also has the point 5, I believe 3, and 1, 3. And this is our function f of x. Pretty soon, actually in the very next section with which we're starting tomorrow, you will be able to tell me what the formula is for that parabola when we talk about transformations of functions. So you have that to look forward to. And we're also going to look at g of x. All right, and g of x is going to be, oh my word. So in my notes, I didn't actually graph these. In my notes, I just wrote the function down because it was simpler. And then but I have to do a lot of transformations in my head. We're gonna go right 3 and up 6. So we do need to go up to 6 actually. Right 3 up 6 is where we start. We start at the point 3, 6. And then we go down. So we have 2, 5. We have 4, 5. And then 1, 2. And 5, 2. And by the way, the reason I'm graphing these by hand is because you can, the reason I'm graphing these by hand is because if you're taking notes, you will also be doing it by hand. But on a quiz or an exam, you will have an actual nice printed off version of these graphs. So they will be much easier to read on a quiz or an exam, okay? So, part A. Find f of g of 1. And this is the same as the previous problem. It looks a little different. There's a different flair, a different color, but it's still a Hawaiian shirt, okay? You start on the inside and say, okay, to start this, we need to figure out what g of 1 is. This is g of x, by the way. Yeah, Monet, good catch. So when x is 1, what is g? It's kind of hard to read, but hopefully you can read it. Someone let me know what g of 1 is equal to. 2, yeah. We find when x is 1, what is the y value or the g value? It's positive 2. Good. So since g of 1 is 2, we replace the g of 1 with a 2. G would be a y-coordinate. It's a function value. So it's just a number, not an ordered pair. The point would be an ordered pair, though. Well, now we need to find what f of 2 is. So we go over to f. When x is 2, the function value is 0. We're on the x-axis. So f of g of 1 is just 0. So ask me any questions that you might have, but also look at part B, g of f of 2. Do part B on your own, but if you're not ready to do part B, if you have questions, now's a good time to ask them. And we're just going to take attendance at the end of class today, I think. Oh, hopefully it's not enough. Oh, crap. F of 2 is 0. I didn't actually show you what the value of 0 was. This is my mistake. I didn't make my graph include enough. G of 0 is actually -3, even though it doesn't really look like it. Sorry about that. Hey, Layla, hope you're ready for some math. So yeah, we just do it before. This is kind of a silly example B, because we already found what f of 2 is, right? When x is 2, f is 0. And f of 2 equals 0. So we just replace the f of 2 with a 0, and we get g of 0. And then over here, yep, very good. When x is 0, what is g? -3. So this is essentially function composition from another point of view. All right. We have one last example problem for today, and then we're going to be done. All right. Hopefully you're surviving today. Hopefully it's getting a little bit better as we do more and more examples. But if not, you can always ask questions on the Discord or via email. Last example of the day, example 6. And then we'll have done most of the section with a little bit of excitement in store for tomorrow. 4. F of t equaling t squared minus t, and h of x equaling 3x plus 2. Find the following. Yeah, attendance is optional. It's just extra credit. If people want to just like watch the videos later, they can certainly do that. And there are alternate extra credit opportunities for people who like have work during this time. Since it was not obvious that this class would be a synchronous online lecture when you signed up for it in the fall. F of h of 1. Is that an x? Yeah, it's a very curvy x. Okay. My x is pretty curvy too. Maybe that's why I draw them that way. All right. So we just start on the inside. We have to figure out what is h of 1. And if you want to go off to the side and evaluate h of 1, you can, right? Because this is what we need. We need to figure out what h of 1 is so that we can plug it in. All right. So h of 1, we just say, okay, plug in all the 1s for the x's. It's going to be 3 times 1 plus 2. That's 3 plus 2 is 5. So it goes in. This is, again, just the same as the last 2 problems. Just one uses a table. The next one used a graph. This one uses functions. Okay, and then f of 5, right, is going to be plug in 5 for t. We get 5 squared minus 5, which, yeah, exactly, is 20. Good. Okay. And part B. And actually, we've been talking so much about function compositions. I'm going to change part B up a little bit. What is f plus, I was going to write a g. It's an h. There's no function g here. What is f plus h of 3. And you might say, oh my word, we've been dealing with function compositions for so long. What do we do with this plus? And remember, it's just f of 3 plus h of 3. These ones are the easy ones, which is why we're not doing very many of these. But if we don't do any of the easy ones and you just don't remember how to do it, then of course they're not easy anymore. If you don't know how to do something, then it's impossible. So this is a little bit of a refresher. So we just find each of these individual. F of 3 is plugging 3 into this. You get 3 squared minus 3. H of 3 is plugging 3 into this. 3 times 3 plus 2. 3's everywhere. The revenge of the 3's. I need to simplify this. You all have calculators. I don't need to do this out. It's going to be 9 minus 3 is 6. 6 plus 9 is 15. 15 plus 2 is 17. All right. So we have not finished the section. And since we have not finished the section, it will not be on tomorrow's quiz. Okay? Remember that tomorrow's quiz is going to be on the sections that have been finished. So it's going to be 3.1 and 3.2. This material will be on Thursday's exam, though. Okay? So you can send the extra credit info while I'm talking about this. I do want to talk about the exam. For extra credit, PM me in, send me the name. Ooh, send me an element from the periodic table of elements. Any element from the periodic table for today's attendance. Okay, and I'm going to talk about the exam. So tomorrow you have a quiz on 3.1 and 3.2. Okay, and actually I should write this down, right? You have a quiz tomorrow on 3.1 and 3.2. And that's going to happen like our other quizzes, okay? You're just going to take them at the end of class. But you have and Wednesday, and tomorrow, let's see, tomorrow in class, we're going to finish the section we're doing right now. We're going to finish 3.4, and we're going to start function transformations. Okay? On Wednesday, we're going to finish 3.5, and this is where things get different. In our face-to-face class, we spent the day before reviewing, a whole day for review. We honestly do not have the time to spend a full day for review. So on Wednesday, we're just going to do 3.5. But 3.5 will not be on the exam. It will be on the next exam. I don't expect you to learn something one day and take an exam on it the next day. So what that means is on your Thursday exam, you're only going to be expected to know up to 3.4. So 2.1, 2.4, 2.5, 3.1, 3.2, and 3.4. It will not cover 3.5. Okay? And there will be no class on Thursday. So Thursday will just be the exam, and you have to take it at class time. If you have work or something, just like with the quizzes, if you have work or something, you need to contact me before the exam so I can schedule a separate time for you to take the exam. Okay? So this will be at 1 p.m. and I'll give you like an hour and a half or something. Okay? That's what's going on. Any questions? Quiz will be at the end of lecture, so around 2 o'clock. Um, 11:35 will be 11:35 will be the quiz on Wednesday for my trigonometry class. This is college algebra. And remember the wigs for next week. Yeah. All right. Well, anyway, good luck. Have a good day and adios.